and I'll just be sharing my screen and going through the presentation this afternoon. And if you do have any questions, please feel free to use the Q&A function. And then at the end of the presentation, we have some time. I'll be able to answer those questions for you. So just share my screen and begin the presentation. So thank you for coming along. Today's presentation is all about forensic science and how we tackle crime in the 21st century and how forensic science has evolved over the last few decades to where it is now. So forensic science, well, what is it? It's the use of scientific methods to assist in the investigation of crime. Forensic science is a fairly common science thanks to a lot of the media and pop culture. And it's used throughout the entire investigation process of related to crime or criminal activity. And I'll go through what that looks like in a few slides. But for those of you that don't know what forensic science is, a really nice way to think about forensic science is to think of it as a historical science. Now, what does that mean? Well, a historical science is a way that we can use science to try and understand the past and the events of the past. So a common example that people might know a little bit more about is archaeology or paleontology, which is the study of fossils or relics to try and understand what happened hundreds, thousands of years ago. And forensic science tries to do the same, but rather than trying to look at relics or fossils from hundreds or thousands of years ago, forensic science uses what we call traces. And it helps, those traces will help us try to understand the events that happened not all those years ago, but might have happened hours, days, weeks, months, or years ago. And it's using what gets left behind during a criminal activity that we hope to try and understand what happened. And we try to tell a story, or we try to recreate the events. So what is the role of forensic science? Well, for a lot of us, our understanding of forensic science is linked very much to the idea of investigation. And this is where we focus on a single case or a single crime, and we use forensic science to investigate that, to try and, again, understand what happened during that criminal activity. And this is mostly in the context of policing. So often forensic science is attached to policing agencies, either their national or regional policing departments, and they'll be there to help the police investigate what has happened. Additionally to that, if there is enough evidence and someone is convicted, or they then do go to the court system, the forensic scientists will provide evidence in court and give their opinion of what happened, what analysis did they do, and what did they find during their investigation. And again, the role of the forensic scientist here is to assist the courts in their judgment. But in both of these instances, forensic science is used purely for a singular focus. So it will be focusing on a single case or a single set of events. And this is the way that forensic science has been thought of for, almost since its existence over 100 years ago. But forensic science since then, and I'll talk about this during the presentation, has evolved beyond this single case focus. And it's expanded and evolved. And one area that it's moved into is into the area of intelligence. So intelligence is a way that we can use forensic science to better understand crime and criminal phenomena. And by not just focusing on a single case, but taking what we call a multi-case approach, looking at all the different elements of multiple crimes, we can use this information to generate data. And then this data can then help us to understand trends. And when we understand trends, we can start to potentially disrupt that crime. We can target resources to be more effective in preventing crime from occurring. And it's, through this additional layer of forensic science that in the future and then where we are now with forensic science, we are sort of balancing the scales, I guess, in terms of moving away from just the single case focus, which we will still do. That's still something that forensic scientists will do. We're there to still assist policing agencies and the courts. But in addition to that, where we can expand our role and move into this forensic intelligence realm. So if we think about traditional forensic science, again, when I say the word forensic science, people might have certain ideas already coming out. And the most popular sort of disciplines within forensic science are things like fingerprints. So you've maybe seen some television shows, or if you've gone traveling, people might have collected your fingerprints as you entered the border, because we would use fingerprints to identify an individual. And fingerprints have been used in forensic science for over 100 years now. It's one of the first tools that we had in forensic science. And it's a way that we can really identify a specific individual. Another common form of identification is what we call DNA. Again, you may be familiar with this if you've seen or read any sort of true crime fiction or true crime novels or listened to podcasts. And again, DNA is an identifying characteristics that we can use to identify a person, and DNA is prevalent in a whole range of parts of our bodies. It's in our hair, it's in our saliva, it's in our blood, and both of these are very strong tools for us to identify an individual, particularly whether it's a victim or if it's a suspect, to again try and understand what happened during a criminal activity. Now, one of the oldest elements of forensic science was around the analysis of documents and handwriting. So acknowledging that a lot of what we do now is online. We don't tend to put too much pen to paper anymore, but how somebody writes is also a way that we can identify somebody. And it's not just how they write. Everybody writes differently, but we can also do analysis on the pens that people are using, because different pens will react differently, and we can see if there's been any additions or changes to the handwriting. Down there, we've got explosives and gunshot residues. So again, anytime there's a explosive or a gun that's been fired, it will leave behind chemical residues that we can analyze in the laboratory and try to understand who fired the bullet, or who what type of explosive was used. And that's particularly in the sort of terrorist attacks that have happened over the last few decades. Then there's forensic pathology and taphonomy. And so this is the investigation of human remains, and again, trying to understand what happened that led up to the cause of somebody passing. And the study of taphonomy is what happens to human remains after a period of time. And at the University of Technology, Sydney, we do have a very unique facility where we're able to research using human donors, what happens to human remains when they're exposed to different environments. And you may have read that they're called body farms, where essentially we're able to study how humans decompose. And that's really useful information that we can then share with policing agencies, particularly if they're recovering remains that might have been buried for quite some time. And then the final one there is actually the one that's really growing over the last few years, and it's at the area of digital and mobile forensics. So if you think about our lives and our day-to-day lives, more and more of what we're doing is online. I use the example of handwriting, and 20 years ago, we would have to, go to the bank and write a check, and we would use a pen to write that check, and that pen, the handwriting that we use could then be linked to us. But now with mobile banking, everything's online. We don't need to go to a bank anymore, but there are still traces of our activities, but it's just online. And this area of, digital forensics, and then even mobile forensics. So our mobile phones, I don't know about anybody else, but I tend to use my mobile phone quite a lot. And within my phone, it has GPS data and information, so it can track my location at any time, any phone calls that I take, websites I visit, what I'm scrolling or liking on Facebook, Instagram, TikTok. All of that data is being collected in our mobile phones, and if needed for criminal investigations, we're able to analyze those digital traces to better understand, again, what might have happened, where someone might have gone. Additionally, things like closed circuit television, so CCTV footage. Again, there's cameras more or less everywhere that we go, and that can then be recorded. And if we want to track somebody's movements or understand if somebody's gone missing, where were they last seen, what had happened, there's a whole suite of these digital traces that we can use. So again, understand what might have happened. So the role of the forensic scientist, and so this is the sort of, the 4 stages of what a traditional forensic scientist would do. But then there are, some slight tweaks when it does come to that digital forensic side of things. So traditionally how it would work is that a crime would be reported to police. And the role of the forensic science, as I've said before, is to try and understand what happened during the time that the crime occurred. We're never going to be at the crime scene right when the crime is occurring. So we need to collect enough useful and relevant traces to help us understand what's happened. So the first set of forensic scientists will be what we call our crime scene officers. And they'll attend the crime scene with the police, and their goal is to make sure that they collect enough relevant traces to help investigators. So we've got this image here, and again, if you've watched any crime television shows, you might be imagining people more in designer outfits and looking very, very nice and fancy, but this is the uniform of a crime scene officer. We want to be making sure that we don't contaminate the crime scene with any of our hair or fingerprints. So we always need to make sure that we're wearing, these bodysuits, we're wearing masks, we're wearing gloves, and we're making sure that we're not compromising the integrity of the crime scene. And the key word there as well for those crime scene officers is relevant traces. So depending on how big a crime scene can be quite large, depending on the type of crime that's occurred. And you imagine that there's a lot of things that can be collected, but just because they can be collected doesn't mean that they're going to be of value. So there is a crime scene officer really does need those scientific skills of critical thinking, and analytical problem solving, so that they know what's going to be of the most value. If they go and try to collect everything, it will just create a large backlog for the laboratory. So, you know, as a forensic scientist, just like any scientist, they'll create hypotheses. They'll try and understand what might have happened, and so that they can, you know, target specific areas, so that they'll get the best chance of finding out what happened. Now, again, slightly different to what you might have seen on television. The forensic scientists who attend the crime scene are not the same forensic scientists that will then go into the laboratory. Those are two different roles. Those are two specialized roles. And so the people that collect the crime scene traces will then get them shipped off to the laboratories, where they'll be sent for different types of tests. And so, just like we saw in the previous slide, with all those different sections of forensic science, depending on what the crime scene officers will collect at the scene, they will send them to the relevant lab. So if they want to test something for DNA, it will be sent to the biology lab. If they want to check something for fingerprints, they'll send it to the fingerprint lab, documents to the document lab, all of those sorts of, you know, there's specific experts that will work on specific tasks. And the goal of the lab scientists is to try to establish a link. And depending on what it is that they're analyzing, the link might be between a suspect and the crime scene. You know, if a suspect has left behind some DNA, then if we recover that suspect's DNA from the crime scene, we've established a connection there that wasn't there. So we can say with a degree of certainty that that suspect was present at the crime scene. It might be between the crime scene and a victim. So say, for instance, there's a crime that occurs, and then the victim moves to another location. And again, we might use DNA, we might use fingerprints, we might even use things like footwear, or even things like just their hair, not necessarily for DNA, fibers from their clothes, all of these things that we can do to try and establish a connection. And it's through establishing these connections that we're able to, again, piece the story of what happened, try and understand the sequence of events. And then the final thing is, if a suspect is identified, then there may be required to give evidence in court. And so as a forensic scientist, we are there to provide our opinion on the evidence that we've analyzed, or the traces that we've analyzed. We are not there to establish guilt or determine whether somebody is guilty or committed the crime. So that's something for the judge or the jury to decide. We are just there to provide our opinion. All right, so how have we seen forensic science evolve over time? Well, for a very long time, traditional forensics focused mostly around fingerprints, human remains, handwriting, explosives. These were the more traditional sciences that we saw happening there. Then in 1980, so even though DNA is seen as an excellent tool in forensics and appears to be quite well established, it's, in the grand scheme of things, only 40 years has it been, it's only been in use for forensic purposes for about 40 years, which when we compare to other methods which have been in use for over 150 years, it's quite new. But with the introduction of DNA, it introduced more complex things. And then we had mobile phones. So again, there's a very old school mobile phone, but the information that forensic scientists could get from that mobile phone, again, location, conversations, phone calls, were all things that we didn't have access to. But again, it introduced more complexities. It was not something that we could test in the lab. It's something that we needed to test using computers, and the computing power at that time wasn't very strong. And then we had the internet, which really opened up a whole range of new sources of data, but also new types of crime. You know, as our mobile banking and our identity became more and more online and more on the internet, crimes around identity theft, bank fraud, all of these things moved from the physical space into the digital world. And then now, with AI and the way that AI is moving, we cannot even be sure if the person that we're talking to on one end of the internet is indeed actually a person. And things that are produced can be produced by AI, and there's some really interesting things going on, as you're probably aware, in a whole range of different areas, whether it's art, it's ChatGPT, and this is again going to introduce more complexity into what we do as forensic science. So crime has definitely evolved with these new tools. And so as forensic scientists, we always want to try and be one step ahead. And we always want to be making sure that we stay up to date with where it's going. And so if we think about where forensic science is now in the 21st century, for a very long time, we were only ever focused in the physical world, collecting and analyzing physical traces to then try and make connections between the physical crime scene, our offender or suspect, and the victim. But now we have to also consider the digital crime scene, the GPS data, the internet searches, the mobile phone data, the photos that they take, whether they're sending messages to people. All of these things now are being added into our criminal investigation processes, and it is generating quite a lot of data. And it's what we do with that data that's going to change the way that forensic science operates. And it's a really exciting time because it's what we call the digital transformation of crime, and making sure that we stay that one step ahead of the criminals. And so this diagram here, it just shows you how forensic science fits into a lot more broader areas. So again, when we think of forensic science, we might traditionally think that forensics is only for the purposes of policing or assisting in the courts. But as I mentioned earlier, the skill set that a forensic scientist needs, those critical thinking, problem solving, investigative skills, are transferable beyond just the criminal justice system. And because forensic science is so broad in what we do, you know, we have on the left here the enabling disciplines. So, you know, chemistry feeds into forensic science quite easily if we're looking at things like illicit drug detection and analysis, or even just general fingerprinting. Physics, if we're doing things like bloodstain pattern analysis, or vehicle forensics, where we try to investigate, you know, if a crash has occurred, what was the speed of the two cars that happened at the time of the crash? Did somebody put their brakes on, or were they speeding at the time? Biology, again, that sort of DNA, IT and computing is again feeding into that for digital forensics. Social sciences, so there's a whole other branch of criminal investigations called criminology, and that's looking at the psychology of crime and criminal behavior. So all of these enabling areas can then feed into a forensic application. So we've got things like drugs and forensic toxicology, criminology, taphonomy, the investigation of human remains, digital forensics, biometrics, forensic intelligence. And it's through this study of the trace. So it doesn't matter whether it's a chemical, a biological, or a digital trace, the forensic scientist is able to use them to then understand crime and criminal phenomena. And then we have our end users. So who are people that employ people with forensic skills? So, you know, we've really identified that the criminal justice system is the common end user, but more and more we're seeing people in security and defense requiring the specialized knowledge of a forensic scientist. Particularly in the area of our digital forensic scientists, we see quite a lot of graduates moving into the areas of banking or even accounting because they're obviously, as I said, banking is going online. We need to make sure that all of our digital assets are secure. And then if there is a breach in a data breach, we need to have people who can investigate what's happened so that it doesn't happen again. Public health and public policy. So again, using that, you know, forensic intelligence data to understand crime a bit better, we can inform politicians to or policymakers to make changes to laws that might reduce crime or reduce the impact of crime. So this slide is just really here to say that, you know, while we think about forensic science in the past, it might have it has a, you know, a more direct link to policing. As crime has evolved, so has forensic science to be a lot more broader in terms of where its skills are needed. So I'm going to go through an example in a bit of specific detail, just to give you a real, you know, I guess a case study on how forensic science has evolved over time. And if we use the case of illicit substances, and illicit drugs has and continues to be a problem for society. And traditionally, from a forensic perspective, when it comes to illicit drugs, we would only be focusing on prosecuting individuals who have either had in possession or sold illicit substances. And so that's what we call that sort of individual case-by-case focus. If you know, someone is smuggling some drugs into a country, or they've got some on their person that is illegal, they'll be you know, investigated, potentially prosecuted, and then the cycle will more or less continue. It doesn't disrupt the behavior. It disrupts the individual, but not the overall criminality. And so the knowledge and understanding of the illicit drug problem is purely limited by what we were able to get from these individuals that we've prosecuted, or things that we seized. The data that we were getting is only coming from one sort of part of society. And if we really want to understand the problem and then come up with solutions that are going to be, you know, more impactful, we need to take it from a few different angles. And this is what we're doing now in forensic science. And some of the examples I'm using here are related to some of the research that we do at UTS in the Centre for Forensic Science. So you can see that this is quite current and relevant. So if we want to try and have greater knowledge about illicit drug trafficking and consumption, one way that we can do that, and it's one of the ways that we've been doing it for quite some time, is doing what we call profiling. So this is where we will collect a illicit drug, whether it's from an individual, whether it's from a laboratory that's making it, whether it's coming in through border seizures. We'll analyze it and we'll get what's called a profile. And that profile will tell us what type of drug it is, how it was made, are there chemicals mixed into it. And again, that's been the way that we've been collecting information for quite a long time, and it's been helpful, but it's what we call reactive. we can only analyze and understand those drugs when we seize them or we recover them. So it's again that sort of one source of information. Other ways that we can try to understand how people are using them is doing what we call wastewater analysis. So all of the water that that gets flushed down the toilet goes into centralized water systems, and we can collect water samples from those sort of collection areas. We can treat it, we can analyze it, and then we can calculate the amount and type of drugs that are being used within a specific region. And this research has been done in Sydney, but also in parts of Europe. And it gives us an understanding of, what are the individual countries' drug usage, depending on what gets flushed down the toilet. We can also analyze used paraphernalia. So in certain countries, they have what we call safe injecting rooms, where for people who inject drugs are able to have access to clean needles and paraphernalia. And this is for a health purpose, so that they're making sure that they're not using, dirty needles, spreading disease, those sorts of things. And so we can collect the needles after they've been used to understand what type of drugs are people injecting. Are the drugs that people say or that they're going to inject, are they correct? Are there other agents being mixed in there? Again, this is sort of parallel to that profiling of illicit drugs. And all of these sit very much within the traditional science chemical side of what we do. But then if we move over to our digital world, we can look at online forums. So a lot of the people who use drugs will share user experience, share stories, ask questions online. And so we can extract data from these discussion forums and see what discussions are going on. We can collect this information about what people are interested in before they even attempt to use drugs. Crypto markets. So crypto markets are an element of the dark web, and these are sort of these are websites or like marketplaces where people can, like eBay, put something up for sale, and then through Bitcoin and through a few backdoor tricks, ship the illicit substances to an individual. And the police, they're pretty good at shutting down these crypto markets quite regularly. And what we're able to do is we're able to take the data from those crypto markets, see what was sold, how much was sold, who was selling it, where drugs were being shipped to and from, again, to try and understand the bigger environment. And then finally, we can also do surveys. We can survey individuals who inject drugs, try and understand what is their drug of choice, these, what's their history with drug use. So again, and all of this information that we collect as forensic scientists can then be fed into different areas. So the used paraphernalia and the surveys, some of that information might be more relevant and useful to health departments, so they can provide targeted health support. Maybe the analysis of the crypto markets and the forums. If there's a new drug that's becoming quite popular, we can feed that information to policing agencies so that they can be on the lookout for those sorts of substances. We can then feed that to the forensic laboratories. They might need to come up with new methods to analyze these new types of drugs. And so it's by using all of these different sources of information to piece together what's happening in this space to get a better understanding of crime and criminal phenomena. And this is just one area that we do this in forensics. We do this type of analysis to try and understand, criminal behavior beyond just illicit drugs. And it's just here to show you that forensic science is a lot more broad and has very much evolved from where we may think it sits as purely a lab-based science. And so I guess a summary here is that forensic science in the 21st century is really the combination of the digital and the physical world. And where that overlap occurs is where forensic science is currently sitting in. And it's a really exciting time in forensic science to see how this has evolved. And so I just wanted to, talk to you a little bit about forensic science at UTS. And so we do offer a few courses at different levels. So just generally in the forensic science program, we have a Bachelor's of Forensic Science and a Master's. In the Bachelor's, we offer 4 majors in chemistry, biology, crime scene investigation, and digital forensics. And at the Master's, we have an extension, which is a 2-year program, and a philosophy stream where you're able to do a research component. Just generally in forensic science at UTS, so it is a world-leading forensic science program. It is the first and best forensic science program in all of Australia. And we are backed by the research centre, the Centre for Forensic Science, which is a high achieving research centre in the university and globally within forensic science. So I've talked a lot about the rise of digital traces, and I just did want to draw your attention specifically to the digital forensics major that we do offer. It is the first and only undergraduate digital forensic science program in Australia. And we've chosen this program because of where we're seeing the world moving and the cybercrime, continually growing and costing the world more and more over time. And I think the other thing to remember is there can sometimes be a bit of confusion around things like cybersecurity, digital forensics, and they're used quite interchangeably. So just to sort of clarify, cybersecurity is very much about understanding how best to protect our assets online. And it's all about trying to make things more secure. So someone who works in cybersecurity is about building up their defenses. They're trying to make it as impenetrable as possible. Where digital forensics comes in is, without a doubt, there will be a breach. Something will happen. That cybersecurity component will not be perfect. So the digital forensic investigator is the person who goes in after an attack has occurred or a breach has occurred and tries to understand, how did that breach happen? What was the chink in the armor that caused this attack to happen? And using their forensic skills and the investigative skills, they will make recommendations for how to make the site more secure and how to prevent it from happening in the future. So that's a really, I guess, a neat way to think about. There's both roles, there's space for cybersecurity and digital forensics because they are 2 complementary roles that, are achieving slightly different outcomes. So with our postgraduate program, this is at the master's level. You have the same sort of opportunities. It doesn't allow for specialization in the level of the majors, but it does allow you to get more technical in forensics. So if you're coming from a previous scientific background, you have the opportunity here to specialize in forensics, and you have an embedded research component as well. You might have you'll have the opportunity to work alongside the leading research academics in forensic science at UTS. So I just wanted to summarize the presentation today. So forensic science does cover a broad range of disciplines that do aim to assist police and the court in the investigation of crime. However, it has evolved with the rise of digital traces and mobile devices to where we are now, where forensic science are needed and valued outside traditional policing and investigative careers. So this comes to the end of my presentation, and I would be more than happy to answer any questions that people might have. I can see that there's already some questions in the Q&A, so feel free to continue, and I'll answer those questions as they come in. But thank you for listening and attending. So we did have a question. So who performs an autopsy, and can this program lead me to this career in Australia? So people who conduct an autopsy are deemed what we call forensic pathologists. And a forensic pathologist has a quite a long study to be conducted. You will need to do an undergraduate in science. It can be in forensic science. It would be recommended that you would choose the biology program because the next step is that you would need to become a medical doctor. Then once you become a medical doctor, you will then need to specialize in forensic pathology, which is an additional couple of years on top of that. So all in all, it ends up being about 12 years of study before you can become a forensic pathologist. However, the people that conduct autopsies, while the forensic pathologist is the lead person, there are other roles as a part of the investigation of human remains, and people with a forensic science background, specifically in the forensic biology major, have that as an option in that they can become a mortuary technician, a forensic mortuary assistant. Those sorts of roles are available to people who complete this program. Do forensic scientists only work in police departments? No. So forensic scientists can work with police. That's, again, a very common pathway. But the way that we've designed the courses at UTS is to provide students with enough skill beyond forensics that they can achieve employment outside of policing. So, for instance, in the chemistry and biology majors, forensic scientists can go into police labs, do DNA profiling and things like that, but they can also move into adjacent careers. So in the biology programs, we have a lot of our graduates working as hospital scientists, where they'll be, again, analyzing, different samples, but not necessarily for police investigations. It might be for hospital or health related investigations. Similarly, with our chemistry program, they might be working into pharmaceutical companies. They could work for companies like Pfizer in terms of their drug discovery side of things. It could be formulation chemists for synthetic chemistry companies. And we also have the digital program, which has the highest graduate outcomes. In fact, a lot of our graduates get jobs before they even graduate, just because they're in such high demand. And we've been running this program for now almost 5 years, and the graduates are more likely to be employed in a private sector, so PwC, Deloitte, Corda Mentha, CyberX are all places where our graduates have ended up. So they've been snapped up by private companies before they can even move into policing. So the digital area is really one that the job opportunities are growing, and they're a lot more broader and we've had quite a lot of international students as well, been quite successful in that program. Studying an A level, and I'd like to check if there are any scholarships provided. So the scholarship opportunities for UTS are available on our website. There's some information there about scholarships and the alignments there. The scholarships are quite generous in terms of what they offer, and there are some good scholarships available for international students. So I would recommend that you head to the UTS website and check out some of the information around scholarships for international students. And then the most popular major in the forensic science program. So our most popular major is our crime scene investigation major. That's mostly driven by students' interest in crime scene and forensic science, what they see on TV. And that specific major does train people to be on a pathway to policing, if that's what they're interested in. And then subsequent to that, we have the biology major is the next most popular, followed by the chemistry and digital major sort of close behind. But the crime scene major is more popular with local Australian students because they're seeing this as an opportunity to get into a policing area, whereas the other majors are a lot more open and amenable to international students. All right, so there are no other questions in the chat, but if you do have a question, I'll more than happily answer it. I'll give it another minute or two, but if there are no other questions, I'd again like to thank you for your time and to come to this seminar this afternoon, and hopefully you've learned a little bit more about forensic science, not just at UTS, but also in the 21st century.